Hello, and welcome to Space for Sleep. I'm truly glad you found your way here tonight. Maybe you're lying beneath a warm blanket, your room dim and quiet, or maybe you're just letting your mind drift between thoughts. Wherever you are, this is your moment to breathe, to slow down, and to wonder. Because tonight, we're taking a gentle journey outward, far beyond the blue of our skies, past the hum of our solar system, and into the deep, endless ocean of space itself. Together, we'll try to glimpse the unimaginable, just how vast our universe really is, not to solve it, not to measure it with numbers alone, but to feel it, to sense the scale of something so enormous that even light, moving faster than anything we know, needs billions of years just to cross it. So, let's close our eyes, open our curiosity, and begin. When we first look up at the night sky, what we see feels almost familiar. Pinpricks of light scattered across a dark canvas, quiet and eternal. But that simple view hides a truth so large, so staggeringly beyond our senses, that even our imagination trembles trying to hold it. The universe we live in isn't just big, it's vast in a way the human mind was never built to fully grasp. Every star you can see with your naked eye belongs to our Milky Way galaxy, a single city of stars among hundreds of billions more. And within that city, our sun is only one of roughly 400 billion lights burning across the spiral arms of space. If you could travel at the speed of light, nearly 300,000 kilometers every second, it would still take you about 100,000 years just to cross our own galaxy. Think about that. Every heartbeat, every breath, every year of human history, and you'd still be nowhere near the edge. And beyond that edge lie more galaxies, each filled with its own suns, its own planets, its own possible skies. Astronomers estimate there may be more galaxies in the observable universe than grains of sand on all the beaches of Earth. Each grain, each galaxy, contains hundreds of billions of stars. When we point our most powerful telescopes into what looks like an empty patch of sky, the darkness blooms with thousands of galaxies. The Hubble Deep Field image, taken over many nights of patient observation, revealed a breathtaking secret. Even the quietest corner of the cosmos is overflowing with light. That single picture became a window, showing us that the universe isn't a lonely place, it's a crowded, glittering expanse. Yet as vast as that observable universe is, it's only a fraction of the whole. The word observable is a kind of humble admission, a reminder that light takes time to travel. What we see is limited to the distance light has reached since the beginning of time. Beyond that horizon, beyond the edge of what we can ever observe, lies more universe, perhaps infinite, perhaps folding back on itself, perhaps full of structures we will never touch or measure. In this endlessness, distance itself becomes almost meaningless. The light that enters your eyes tonight may have started its journey before Earth even existed. Some of the faint stars above you could already be gone, their light still crossing the silent gulf, long after their fires have died. When you gaze upward, you're not looking at the universe as it is, you're looking into its memory, a cosmic archive written in light. It's humbling, isn't it? To realize that even our greatest machines, our most daring missions, have traveled only a whisper of this enormous sea. The Voyager 1 probe, launched in 1977, has been sailing outward for nearly 50 years, and it has just barely stepped outside the boundary of our solar system. If the Milky Way were the size of the United States, Voyager hasn't even left the front yard. And yet, we keep reaching. We keep building sharper eyes to see farther, faster minds to calculate deeper truths. Because somewhere within us is a quiet need to understand the place we come from and to measure, in whatever small way we can, the scale of the mystery that surrounds us. So, tonight, as we drift through this journey together, let's slow down enough to feel that mystery. Let's trace the universe step by step, from our familiar home to the edges of what we can know. Because in the calm of curiosity, even infinity feels a little closer. As we step beyond our Milky Way, we enter a universe of neighbors, galaxies of every shape and size, spinning silently in the cosmic dark. Some are elegant spirals, like our own home, with arms curling gracefully around their luminous centers. Others are massive ellipticals, glowing faintly, filled with stars that have been burning for billions of years, their light stretching out in a soft, ancient haze. And there are irregular galaxies too, scattered like cosmic brushstrokes, each telling a story of collisions, births, and slow dances across time. Galaxies rarely exist alone. They gather in clusters, sometimes containing hundreds, sometimes thousands of individual galaxies, all bound together by the invisible pull of gravity. Imagine floating through such a cluster. Stars from neighboring galaxies would seem impossibly distant, but their collective light would create a subtle glow, a faint cosmic warmth that hums quietly across millions of light-years. These clusters, in turn, assemble into even larger formations, called superclusters, stretching across hundreds of millions of light-years. Within this vast network, the universe reveals a hidden architecture, a cosmic web made not of solid matter, but of invisible threads of dark matter, along which galaxies and clusters align, as if following an unseen pattern drawn at the birth of time. The scale here is almost impossible to comprehend. If our sun were reduced to the size of a tiny marble, the Milky Way would stretch thousands of kilometers across, and the nearest galaxy, Andromeda, would still be a marble floating far beyond the horizon. And even that is just a single step in the enormous staircase of cosmic distances. Entire superclusters, each containing countless galaxies, drift silently, pulled along by the subtle tug of gravity over billions of years. And yet, the universe is not still. It's stretching, expanding in every direction. Every galaxy, every star, every speck of light is moving away from each other, carried gently on the swelling fabric of space itself. The farther a galaxy is, the faster it seems to recede, a phenomenon first discovered by Edwin Hubble nearly a century ago. In this slow, quiet motion, we glimpse the echo of the Big Bang, the gentle exhalation of creation itself. The universe is not only vast, it is dynamic, alive in its own enormous rhythm, growing and shifting on a scale our minds struggle to hold. It can feel almost lonely, this immense scale. Yet, in that vastness, there is a strange intimacy. Every atom in your body was forged in the heart of a star, many of them long dead. We are stitched into this cosmic web, part of a universe that is both incomprehensibly large and intimately familiar. When we look out, we are also looking in, a reflection of ourselves in the grandeur of space. And as we float further into this meditation, let's imagine moving past the superclusters, past the glowing webs of galaxies, into the quiet stretches where the universe thins into dark, unlit expanses. In these regions, even the faintest light of distant stars cannot reach, yet they are as real as the stars themselves, filled with mystery and possibility. In the calm of night, in the soft silence of thought, we can almost feel the rhythm of this enormous universe, vast, unending, and breathtakingly beautiful. As we drift further into the universe, we begin to notice the hidden stories written in light, the slow, graceful cycles of creation and transformation that have been unfolding for billions of years. Every star you see above began its life in a cloud of gas and dust, a nebula glowing faintly in the darkness. These clouds are the nurseries of the cosmos, vast and silent, where gravity gathers material slowly, almost imperceptibly, until a new sun flickers to life. Picture a single star forming in this quiet place. For millions of years, gas and dust swirl, contracting under gravity, heating until nuclear reactions ignite in its core. And then, a star is born, a tiny furnace in the vast cold of space, radiating energy, shaping the worlds around it. Some stars burn gently, small and steady, lasting for tens of billions of years, their light a soft, comforting glow. Others burn fiercely, massive and bright, living fast and dying young, destined to end in spectacular explosions called supernovae. Supernovae are the fireworks of the universe, scattering elements forged in the heart of stars across the cosmic canvas. Iron, oxygen, carbon, everything essential for life, is cast into space, drifting until it finds a new home in another star, another planet, another possibility. Every atom in your body was once part of a star, long gone, yet still present in the quiet glow of the night sky. There is something profoundly humbling in that thought. a gentle reminder that we are woven into the fabric of the universe itself. Some stars, however, end not in quiet fade, nor in brilliant explosion, but in the darkness of black holes. These are the universe's most mysterious objects, regions where gravity is so strong that not even light can escape. We can only sense them through their influence, how they tug on nearby stars, bend the path of light, or draw in surrounding matter with a slow, inevitable pull. Black holes are not only the remnants of massive stars, they are reminders of the extremes of nature, where the laws of physics as we know them stretch to their limits and where our imagination must expand to keep up. Nebulae, supernovae, and black holes form the invisible scaffolding of cosmic life. They are the rhythm of creation and destruction, a slow, deliberate dance that continues unnoticed by human eyes, yet shapes everything we see. When we look at a distant nebula, glowing softly in the night sky, we are witnessing both a beginning and an end, the quiet pulse of a universe that is constantly making and unmaking itself. And in the spaces between these stars, between these galaxies, lies the vast emptiness we call the cosmic void. It is not empty in the way a room might be empty. Rather, it is full of possibility, a silent stage upon which the drama of the universe unfolds. Light travels through these voids, carrying whispers of distant worlds, and for a moment, if we listen closely, we can feel the slow, steady heartbeat of creation itself. As we continue our journey, imagine floating past the bright clouds of nebulae, past the blazing young stars and the silent black holes. Feel the calm of this immense space, a quiet so deep that even your thoughts seem to slow, and your mind stretches gently toward the infinite. Here, in this slow meditation on the cosmos, we begin to understand a little of the vastness we are exploring, a universe not only vast in size, but rich in life, light, and the echoes of time itself. As we float farther into the cosmos, the true enormity of the universe begins to reveal itself, not only in the stars and galaxies we can see, but in the invisible threads that shape everything we know. Dark matter, a mysterious substance that neither emits nor absorbs light, weaves through space like a hidden skeleton. We cannot see it directly, yet its presence is undeniable. It tugs gently at galaxies, holding them together, shaping their rotations, and guiding the formation of clusters across the cosmic web. Without it, the universe as we know it would not exist. Beyond the galaxies, beyond even the vast filaments of dark matter, space itself stretches. The universe is expanding, and it has been since the moment of the Big Bang. Imagine each galaxy as a tiny mark on a balloon. As the balloon inflates, every mark moves away from the others, not because they are flying apart, but because the surface itself is growing. This expansion is happening everywhere, in every direction, carrying with it the quiet drift of light and matter across unimaginable distances. The expansion is subtle, almost imperceptible on human scales, yet over billions of years, it reshapes the universe entirely. Light from distant galaxies is stretched, shifting toward the red end of the spectrum, a phenomenon we call redshift. In this gentle stretching of light, we glimpse the slow, patient breathing of the cosmos, a rhythm that has persisted for over 13 billion years. Even the emptiest regions of space are not truly empty. A faint glow lingers everywhere, the cosmic microwave background, a whisper of the universe's birth, the first light that traveled freely after the primordial plasma cooled. It is the universe's oldest memory, a soft hum that echoes across time and space. By listening to it, scientists have learned not only the age of the universe, but the story of its earliest moments, a time when the cosmos was small, hot, and dense, yet filled with the seeds of everything we see today. As we drift through this immense void, it becomes clear that the universe is both simple and complex. Simple in its elegance, the laws of physics stretch from here to the edge of all we can see, but complex in its richness, filled with structures, patterns, and hidden influences we are only beginning to understand. From dark matter shaping the cosmic web to the faint glow of the universe's first light, everything is connected in a quiet, intricate design. And in this connection, there is a certain peace. For all its size, for all its incomprehensible distances, the universe follows a slow, steady rhythm. Galaxies move, stars are born and die, light travels, and space itself expands. We are part of this rhythm, our own lives flowing in the midst of a much larger cosmic dance, and in the stillness of the night, we can feel, even if only for a moment, the gentle pulse of the infinite around us. As we drift farther, our journey takes us toward the very edges of what we can see, the observable universe. Beyond the familiar stars and galaxies, past the grand clusters and the cosmic web, there stretches a realm so distant, so vast, that our minds strain to hold it. From these regions has travelled for billions of years to reach us, carrying whispers from the infancy of the cosmos. From times when Earth did not exist, and our sun was not yet born, distances in this vast expanse are measured not in miles or kilometres, but in light years. The distance light travels in a single year, nearly 6 trillion miles. Even at the speed of light, which is the fastest thing in the universe, the journey across galaxies takes millions, sometimes billions of years. When we talk about the universe being 13.8 billion years old, we are also describing a scale so enormous that human intuition fails to grasp it. Imagine the edge of the observable universe as a gentle horizon, infinitely far, yet softly glowing with the light of the first galaxies. Each flicker we see is a memory, a record of a time long past. Some galaxies may no longer exist. Some stars may have burned out long before their light reached our eyes. Yet the photons that travelled across billions of years arrive now, quietly entering our telescopes, telling the story of the universe's youth. As we venture even farther, the distances grow almost poetic. A single supercluster may span hundreds of millions of light-years. The voids between them stretch for similar distances, silent and unbroken, dark seas separating islands of light. The universe is not uniform. It is a vast mosaic of structure and emptiness, matter and memory, motion and stillness. And within this mosaic, our own galaxy, our solar system, and our fragile planet are but tiny threads in the enormous tapestry of existence. It is humbling to consider that everything we know, the mountains, oceans, cities, and even the sunlight warming our skin, occupies only a fraction of this immense universe. And yet, in this tiny corner of space, consciousness has emerged, allowing us to reflect, to wonder, and to reach out with questions as vast as the cosmos itself. The observable universe may have a boundary. A horizon defined by the distance light has travelled since the Big Bang, but the universe beyond may stretch on forever, or curve in ways we cannot imagine. There may be regions where stars and galaxies follow laws subtly different from our own, or where light has yet to reach us. The edge is not a wall but a reminder. There is more than we can ever see, more than we can ever touch, yet it all exists, quietly, waiting to be discovered. And in this calm awareness of scale, something shifts. The vastness is no longer overwhelming, it becomes meditative. Each galaxy, each distant star, becomes part of a gentle rhythm, a slow cosmic breath that we can sense even from our small fleeting place within it. To contemplate the universe is to glimpse infinity, and in that glimpse, to find a quiet, profound connection to the endless expanse surrounding us. As we continue drifting through this vastness, we begin to sense not only space, but time itself, the slow, sweeping history of the cosmos unfolding across billions of years. When we look at distant stars and galaxies, we are looking into the past. Light, travelling at its constant pace, carries with it the memory of moments long gone. A galaxy 10 billion light-years away is a time capsule, showing us what the universe looked like when it was less than a third of its current age. The universe has a story, and it is one of quiet patience and gradual transformation. In the first moments after the Big Bang, it was a hot, dense, and glowing sea of energy. Over hundreds of thousands of years, it cooled enough for atoms to form. Slowly, matter began to clump together, gravity guiding clouds of gas into the first stars and galaxies. These early structures were small, fragile, and luminous, flickers of light in the darkness. Over billions of years, stars formed and died, scattering the elements necessary for planets, for life, for us. Galaxies collided and merged, growing larger and more complex. The Milky Way itself bears the scars of countless encounters. each collision leaving a quiet mark in the orbits of stars and the shape of its spiral arms. The universe is alive in this slow rhythm, constantly building, reshaping and renewing itself. Time on a cosmic scale is almost impossible to imagine. Entire civilizations of stars have risen and faded, their light still traveling across the darkness. Some stars that burned brightly in the early universe are gone now, their remnants lingering as black holes or neutron stars. Some galaxies we see may no longer exist, their light arriving just as a gentle reminder that even on the largest scales, nothing lasts forever. And yet, amid this enormous passage of time, there is continuity. Each generation of stars seeds the next, each collision of galaxies forms new shapes, each wave of energy ripples outward into the cosmos. The universe remembers, in the faint glow of distant galaxies, in the distribution of cosmic matter, in the lingering hum of the cosmic microwave background. Every moment, every change, is part of a slow, interconnected history stretching from the beginning of time to the present and far beyond it. As we drift in this timeless expanse, we can feel the vastness of not just space, but the epochs that have shaped it. Billions of years pass in what feels like a single breath. The past and present merge, and the universe, in all its enormity, becomes a gentle meditation on existence itself. And within this meditation, we may find a quiet comfort, the sense that even in the vastness there is a story we are part of, and a rhythm we can feel. As we continue our journey through the vastness of space and the sweep of cosmic time, we begin to notice something remarkable. The universe is not only vast in its expanses, but intricate in its smallest details. Beneath the stars, beneath the galaxies, beneath even the atoms that make up our bodies, lies a hidden world, a delicate and strange realm described by quantum mechanics. At this scale, the rules we are used to, those of motion, weight and distance, begin to blur. Particles behave as both waves and points, existing in multiple possibilities until observed. Electrons do not orbit nuclei in fixed paths, but drift in clouds of probability. And yet, even in this strange uncertainty, order emerges. Quantum mechanics is the invisible scaffolding of reality, governing how atoms form, how light travels, how stars burn, and how the universe itself evolves. Consider, for a moment, that every star we've passed, every galaxy we've glimpsed, is ultimately made of these quantum building blocks. Hydrogen and helium formed in the first moments after the Big Bang, their behavior dictated by subtle quantum interactions. Over billions of years, nuclear fusion within stars created heavier elements, the atoms of carbon, oxygen, iron, and gold, all following the strange, beautiful rules of the very small. And through these processes, the microcosm shapes the macrocosm. The tiniest interactions echo across light years, giving rise to suns, planets, and life itself. Even space itself is not empty. Quantum fields ripple with tiny fluctuations, seeding the growth of galaxies, nudging matter here and there, shaping the cosmic web. And sometimes, in these fluctuations, phenomena emerge so extreme they challenge our understanding. Black holes forming from collapsing stars, virtual particles flickering into existence, and the possibility of multiple universes, parallel to our own, unfolding invisibly alongside our reality. The bridge between the immense and the infinitesimal is astonishing. It reminds us that the vast distances of the universe and the tiny subatomic particles are not separate worlds, but intertwined threads in a single tapestry. Every photon of light traveling billions of years, every distant supercluster, every atom within your body, all obey the same fundamental principles. In that unity, there is a quiet beauty, a profound sense of harmony spanning scales we can barely imagine. As we drift further, it becomes clear that the universe is a meditation on both extremes: incomprehensible distance and minute precision, immense galaxies and fleeting particles. And in this gentle awareness we find a calm curiosity, a deep wonder at the order and mystery of the cosmos, from the vastest cluster to the smallest quark. For every moment we linger here, we are reminded that the universe is as intimate as it is infinite, and that even the tiniest particle holds a story as grand as the stars. As we continue to drift through the endlessness of space, we encounter the universe's quiet mysteries, phenomena so vast and subtle that even our most powerful instruments can only hint at their presence. One of these mysteries is dark energy, an invisible force gently stretching the fabric of space itself. It acts everywhere at once, accelerating the expansion of the universe, pushing galaxies farther apart in a slow, almost imperceptible drift. Dark energy is enigmatic, subtle, and vast, the universe whispering a secret we have only just begun to hear. And then there are black holes, which we have glimpsed before, but which reveal ever deeper wonders the closer we look. Some are born from dying stars, but others are supermassive, lurking at the centers of galaxies, millions or even billions of times the mass of our Sun. They bend space and time around them, creating a quiet distortion in the cosmos, a reminder that the universe is not only vast, but strange in ways we are only beginning to understand. The light that circles these giants before falling in carries stories of immense gravity and motion, like distant sirens echoing across space. The universe itself seems to hold secrets in its structure. The vast voids between clusters of galaxies, the delicate threads of the cosmic web, the subtle glow of the cosmic microwave background, all hint at a story we have only partially read. And as we look forward into the deep future, we wonder, how will this grand expanse evolve? Will galaxies drift ever farther apart, leaving islands of stars in an endless sea of darkness? Will black holes slowly consume matter, or fade into quiet remnants over unimaginable timescales? Even time itself becomes a fluid concept. On human scales, it flows steadily. On cosmic scales, it stretches, bends, and folds around massive objects. The universe, in all its vastness, operates on a clock so immense that our lifetimes are but fleeting blips. And yet, within that scale, we can feel a quiet intimacy, a chance to pause, to reflect, to witness the subtle interplay of forces shaping reality, both seen and unseen. As we drift in this contemplation, it becomes clear that the universe is not simply a collection of stars, galaxies, and particles. It is a story of forces both gentle and immense, of light and darkness, of creation and dissolution, all unfolding across time and space. And in this story, even as the universe grows ever larger, ever stranger, we find a sense of peace. For to witness the vastness, the mystery, and the beauty of all that exists is to feel connected, to understand that, even in the unimaginable scale of the cosmos, we are participants in a quiet, infinite dance. As we drift through the vast reaches of space, it is natural to pause and reflect on our own place in this immense cosmos. From the perspective of the universe, Earth is just a tiny speck, a pale blue dot suspended in the vast darkness, spinning quietly around a modest star in the outskirts of an ordinary galaxy. And yet, despite our smallness, we carry within us the curiosity to explore, to understand, to measure, and to dream. We are made of stardust, literally. The carbon in our bodies, the oxygen we breathe, the iron in our blood, all were forged in the hearts of ancient stars. Each of us carries the memory of the cosmos, a living testament to the cycles of creation and destruction that have been unfolding for billions of years. In this sense, we are not separate from the universe. We are part of its ongoing story, woven into its fabric, connected to galaxies billions of light years away. And in this recognition of our place, there is both humility and wonder. Humility, because the universe is unimaginably vast and ancient, stretching beyond what we can see or imagine. Wonder, because within that immensity, consciousness has emerged, a quiet awareness capable of gazing at the stars, contemplating infinity, and feeling awe. We are small, yes, but we are also remarkable. Observers of the universe, capable of seeing its structure, feeling its beauty, and reflecting on its mysteries. Looking outward, we also see the fragile nature of our own world. Against the backdrop of billions of galaxies, each with billions of stars, Earth is a rare sanctuary of life, spinning silently in a cosmic sea. And yet, within this smallness lies significance. Every thought, every discovery, Every quiet moment of curiosity is a testament to the human spirit, a gentle reminder that meaning does not depend on scale, but on awareness, presence, and the capacity to wonder. So as we continue this quiet journey through space, let us carry both humility and awe. Let us breathe in the enormity of the cosmos and feel our connection to it. Let us marvel at galaxies, nebulae, black holes, and dark energy, while also honoring the simple, profound miracle of being here, in this fleeting moment, aware of the universe and of ourselves. And as we drift in this meditation, it is possible to feel a kind of cosmic serenity, a sense that in the endless vastness we are seen, we are part of something greater, and we are gently cradled by the very fabric of space and time. And now, as we drift toward the close of this journey, we take a moment to simply breathe and let the immensity of the universe settle around us. From the first flicker of starlight to the quiet drift of distant galaxies, from the tiniest quantum particle to the vast cosmic web, we have traveled through space and time, feeling both the enormity and the delicate intimacy of all that exists. The universe is vast beyond comprehension, and yet, within its vastness, there is harmony. Stars are born and die in slow cycles, galaxies drift and merge, and even the darkness between is filled with structure, rhythm, and possibility. The more we explore, the more we see that space is not empty. It is alive with patterns, with subtle forces, and with the quiet memory of creation itself. And we too are part of this cosmic story. We are made of the same atoms, shaped by the same forces, and connected in ways that stretch across billions of years and unimaginable distances. Our lives, brief as they may seem, are illuminated by the light of distant stars and enriched by the mysteries of a universe that has been unfolding since time began. To be aware of this is to feel a profound sense of belonging, a gentle reminder that even the smallest among us is part of a grand cosmic rhythm. So, as your eyes grow heavy and your mind begins to drift, imagine the universe around you, galaxies spinning gracefully in the dark, stars burning softly, black holes bending space, and light traveling across billions of years to meet your gaze. Feel the quiet heartbeat of the cosmos, steady, patient, eternal, and know that you are a part of it. Let yourself rest in this awareness, letting curiosity mingle with calm, letting wonder and serenity coexist. The universe is vast, the universe is beautiful, and tonight, in the stillness of your own quiet space, you are gently connected to all of it. Thank you for joining this journey. May your thoughts drift lightly, like starlight across the infinite, and may you carry the calm awe of the cosmos with you as you rest. When you look up at the night sky, every point of light you see is a story, a memory from the past still traveling toward you. Each star you notice with your eyes, even the faintest one, is already thousands, sometimes millions of years old. You are seeing not how it is now, but how it once was. Light, the fastest thing in existence, still needs time to cross the dark ocean of space. So when you gaze upward, you're looking into history, into moments long gone, frozen in a beam of light that found you tonight. Among those countless stars scattered like dust across the sky, most are small, quiet, and familiar, suns like ours burning with steady patience. But hidden among them are giants, enormous furnaces of hydrogen and helium so huge that they defy human imagination. These are the monsters of the cosmos, the true titans of light. Astronomers call them supergiants and hypergiants. Their atmospheres are so large that if you placed one where our sun is, its surface could stretch beyond the orbit of Jupiter. You could fit billions of Earths inside it, and still there would be room to spare. Yet, despite their size, they live short, violent lives. A few million years. That's all they get before collapsing or exploding in a blaze that lights up entire galaxies. Our sun, by comparison, is small, stable, and quiet. It's a slow-burning star meant to last tens of billions of years. But the largest stars burn bright and die young, the cosmic equivalents of fireworks, dazzling, immense, and fleeting. Imagine it now, a colossal orb of plasma, pulsing and breathing in the vacuum, its gravity pulling and shaping everything around it. The light it sheds could make night into day for any planet nearby. And yet, in the grand scale of the universe, even such brilliance can vanish unnoticed. That's the paradox of space. Even the most powerful beings can shine and still remain invisible from here. So where is the biggest one? The largest star ever discovered? Scientists have searched for it for decades, peering through telescopes that can see not just visible light but infrared and radio waves, scanning the farthest corners of the Milky Way and beyond. What they found challenges everything we thought we knew about the limits of size, light, and heat. Tonight, we'll go step by step, peeling back the layers of space, moving farther and farther until we reach that record-breaking giant, a star so large that it stretches the meaning of the word itself. But before we can meet it, we need to understand why stars grow so large and what makes them stop. Because the story of the biggest star is also the story of balance, the delicate tug-of-war between gravity pulling inward and fusion pushing outward, a dance that every star must perform for as long as it can survive. Close your eyes for a moment if you'd like. Picture the calm blackness of space, endless and silent. A single point of light appears, then another, and another, until the whole sky is alive. Among them, one grows brighter. Its glow is soft but enormous, expanding until it seems to fill your mind. That's where we're going, into the heart of that impossible light. And as we begin this journey, remember, the biggest star in the universe isn't just an object. It's a question, a mystery of how far nature can go before it breaks its own rules. From clouds of gas to cosmic giants, every star begins its life in silence. In the cold, dark clouds of the universe, immense clouds of gas and dust drift, barely moving, stretching across light years. These are the nurseries of stars, called nebulae. To the naked eye, they may seem like empty space, but within them, countless atoms float. Hydrogen, helium, traces of heavier elements, waiting for the invisible spark that will ignite their lives. Gravity is patient, but relentless. Over millions of years, it gathers these scattered atoms, pulling them closer and closer until the center becomes dense enough to ignite fusion. Hydrogen atoms collide, combine, and release energy. At that moment, a star is born, a tiny flicker that will grow into a steady light, warming its surroundings, shaping the cosmos in ways both subtle and dramatic. Most stars are modest in size. Some are born under exceptional conditions. If a nebula is particularly massive, or if several dense regions collapse together, the resulting star can be enormous. Its core burns furiously, producing energy at a rate that dwarfs anything our sun could imagine. The bigger the star, the hotter it burns and the shorter its life. A cosmic paradox, greatness comes at a cost. The largest stars, called hypergiants, push the boundaries of physics. Their immense gravity pulls inward, but their blazing cores push outward with staggering force. They hover on the edge of stability, constantly balancing these titanic pressures. Any small change can trigger massive eruptions, shedding outer layers into space in spectacular displays. These stars are unstable, magnificent, and often unseen, hidden behind clouds of dust or flickering from billions of light years away. Now, imagine standing on a planet orbiting one of these giants. The sky would be overwhelming. The star would dominate the horizon, a burning ocean of fire so wide it curves like a miniature sun over your entire world. Shadows would be sharper than any you know, and the night would feel impossible, like standing inside the heart of daylight. But for astronomers here on Earth, finding the largest star is not about looking at the sky and pointing. It requires calculation, observation across multiple wavelengths, and patience. Light from distant stars can be distorted, absorbed, or scattered by the dust between galaxies, and the universe is enormous. Even the largest stars appear faint and tiny from millions of light years away. Yet the search has revealed remarkable candidates. Stars like UY Scuti, a red supergiant in the Milky Way, stretch across the orbits of planets far beyond Saturn. And beyond our galaxy, even larger stars might exist, blazing briefly before collapsing into black holes, leaving only faint clues of their passage. Each discovery reshapes our understanding of what the universe allows, reminding us how vast and strange reality truly is. So when we speak of the biggest star, we are speaking not only of size but of possibility, of nature pushing its own rules to the extreme. Tonight, as you listen, allow yourself to drift among these distant giants, imagining light that traveled for thousands, even millions of years to reach us, carrying stories of creation, destruction, and cosmic scale. Every hypergiant is a reminder, in the universe, there are no limits to wonder. And as we continue, we'll journey further, past familiar stars, past nebulae, past the edges of galaxies, until we approach the true champion of cosmic size, a star so vast it seems almost unreal. Giants among giants. As we journey deeper into the cosmos, the question becomes clearer. What is the biggest star we have ever found? Scientists have spent decades scanning the skies, measuring starlight, and calculating sizes, all to understand the extremes of nature. One star keeps appearing at the top of the charts, UY Scuti. UY Scuti is a red supergiant, located about 9,500 light-years away in the constellation Scutum. From our vantage point, it appears as a faint, reddish dot, easily lost among countless other stars. But when measured, its size is astonishing. If you placed it at the center of our solar system, its surface would extend past the orbit of Jupiter, engulfing Mercury, Venus, Earth, Mars, and even the asteroid belt. Imagine the Sun, our steady companion, replaced by something more than 1,000 times its diameter. Yet even UY Scuti might not be the ultimate record holder. There are other hypergiants, stars like Canis Majoris and Betelgeuse, each massive, each threatening to expand beyond imagination, and each with its own story of instability and beauty. Betelgeuse, famous for its reddish glow in Orion's shoulder, is in the process of shedding mass. Scientists monitor it carefully, predicting when it might explode in a supernova, an event that will briefly outshine an entire galaxy. These stars are extreme not only in size but in luminosity. The energy they radiate is so immense that it defies ordinary comprehension. UY Scuti shines with more than 340,000 times the brightness of our Sun. Even though it is thousands of light-years away, its light still reaches Earth, a faint whisper across the void, hinting at the enormous power contained within. But why are some stars bigger than others? The answer lies in their birth. Massive clouds of gas and dust can give rise to giant stars, and the chemical composition of the nebula plays a role. Stars with more hydrogen and helium fuel can grow larger, while heavier elements create pressure that can limit size. Yet the universe always surprises us. Some stars break theoretical limits, existing on the edge of what physics predicts, constantly challenging our understanding. Despite our best measurements, there is uncertainty. Distances are vast, light is faint, and dust obscures our view. Sometimes, a star appears larger than it is. Other times, a colossal star hides behind layers of gas invisible to even our most powerful telescopes. And beyond our galaxy, the search becomes even more difficult. Each discovery hints at something greater, something we might not have even imagined. Now, imagine drifting past these giants in your mind's eye. See UY Scuti filling the horizon, a calm yet overwhelming presence. Notice its gentle red hue, the slow pulses of energy radiating outward. Unlike our Sun, which is steady and familiar, these stars are alive with movement, expansion, and occasional eruptions. And yet, from millions of light-years away, their light reaches us, carrying information about their size, temperature, and history. As we continue tonight, we will explore stars that might be even larger, theoretical titans whose existence pushes the boundaries of physics, stars that burn faster, live shorter, and vanish suddenly, leaving behind black holes or scattering their matter into the void. In their brief lives, they tell a story of extremes, a story of how far the universe can stretch before it reaches its own limits. And so, in the quiet of this moment, as you listen, let yourself imagine the vastness. These giants exist somewhere far beyond our comprehension, and yet, through light alone, they reach us, whispering the secrets of their enormous existence, measuring the titans of space. Measuring a star may sound simple, just look at it and see how big it is. But the universe is not so easily measured. Even the largest stars appear as tiny points of light from our vantage point on Earth. The distances are immense, stretching across thousands or even millions of light years. A direct measurement is impossible. Instead, astronomers rely on clever techniques, combining physics, mathematics, and the faint whispers of starlight. One of the most common methods is based on a star's luminosity, the total amount of energy it emits. If we know how bright a star appears from Earth, and we know the distance to that star, we can estimate its intrinsic brightness. By comparing this to models of stellar atmospheres, we can calculate the star's radius. It's an elegant method, but one that depends on precise distances, which are notoriously difficult to measure. Even a small error in distance can lead to a huge error in size. Another method uses interferometry, which combines the light from multiple telescopes to create a virtual telescope with a diameter equal to the distance between them. This technique can resolve a star's surface in remarkable detail, revealing its size, shape, and even surface activity. For example, with interferometry, astronomers have seen that some hypergiants are not perfect spheres. They wobble, bulge, and pulsate, giving each one a unique, living shape. Sometimes, astronomers use eclipsing binary systems to measure stars. When one star passes in front of another, it blocks some of the light, creating a pattern we can observe from Earth. By analyzing the light curves and timing, we can calculate the radii of both stars with incredible accuracy. This method has helped confirm the size of some of the largest stars known. But despite all these techniques, there is still uncertainty. Dust clouds can obscure the view, stellar winds can distort measurements, and stars themselves are dynamic, constantly shedding layers of gas. Some hypergiants lose mass at staggering rates, millions of times more than our Sun, which can make them appear smaller or larger, depending on when and how we measure them. And beyond our galaxy, the challenge becomes even greater. Light from distant stars takes millions of years to reach us, stretched and dimmed by the vast distances. Many of the largest stars may never be directly observed, only inferred from their brightness, temperature, and the effects they have on their surroundings. Some might explode before we even detect them, leaving behind only faint clues in the cosmic tapestry. Despite these difficulties, astronomers continue to push the limits of observation, scanning the heavens with increasingly sophisticated instruments. Space telescopes, infrared detectors, and radio arrays allow us to see through dust and across light years, unveiling the true scale of the universe's giants. Every new measurement brings us closer to understanding how big a star can truly become and what lies beyond the extremes we have already discovered. Now, imagine drifting in space beside one of these giants, watching its surface ripple and glow. From millions of miles away, it seems eternal, yet it is fleeting, a cosmic heartbeat of fire. Its size is almost incomprehensible, yet through the patient work of scientists, we can begin to grasp its scale. And as we continue, we will journey toward even more mysterious giants, those that may exist only in theory, waiting to be confirmed by the next generation of telescopes. The limits of immensity. Every star, no matter how enormous, is bound by the rules of physics. Gravity pulls inward, trying to collapse the star into itself, while fusion in the core pushes outward, creating a delicate balance that keeps the star from vanishing entirely. This equilibrium determines not only the life of a star, but also its maximum possible size. Astronomers have long wondered, how big can a star truly get? Observations of hypergiants like UY Scuti suggest there is an upper limit, a threshold set by the delicate tug-of-war between gravity and radiation pressure. Beyond a certain size, a star cannot hold onto its outer layers. Its own light becomes so powerful that it literally blows away the gas surrounding it, shedding mass at astonishing rates. This process, called mass loss, prevents the star from growing indefinitely. Theoretical models suggest that the largest stars could reach several thousand times the diameter of our Sun. But even then, they would be unstable. The outer layers would puff up and fall off. Eruptions would scatter immense clouds of plasma into space, and the star would shrink slightly, only to expand again. It is a cosmic cycle of creation and destruction, a slow dance at the edge of existence. Temperature plays a crucial role. Extremely massive stars are also extraordinarily hot. Their cores burn hydrogen at blistering speeds, producing energy far beyond what smaller stars emit. But this furious energy output shortens their lifespans dramatically. While our sun will shine steadily for 10 billion years, the universe's largest stars might live for only a few million. Their brilliance is brief, yet it leaves an indelible mark on the cosmos. And then there are the theoretical monsters, stars that may exist but remain beyond detection. Some models predict stars dozens of thousands of times the sun's size, perhaps forming in the early universe, when the cosmic environment was different. These primordial stars, called population 3 stars, may have been enormous, burning intensely, and seeding the universe with the first heavy elements. If any of these giants still exist, they would be almost impossible to see directly, hidden in distant galaxies or long since transformed into black holes. It is humbling to realize that the universe may hold stars so vast, so extreme, that they defy imagination. And yet, even the largest of these giants obey the fundamental rules of nature. They shine, they expand, they lose mass, and eventually they die. Often in cataclysmic explosions that scatter elements into space, providing the raw material for planets, life, and even future stars. So, as you listen tonight, picture one of these titanic stars floating silently in the void, its surface glowing, pulsating with energy, unstable yet mesmerizing. It is enormous beyond comprehension, yet fragile, existing on the edge between creation and collapse. These stars remind us that the universe is a place of extremes, a realm where imagination meets the laws of physics. And ahead, in our next section, we will explore what happens when these giants reach the end of their lives, how they explode, collapse, and sometimes disappear entirely into the mysterious darkness of black holes. Life, death, and cosmic fireworks. Every star has a beginning and an end, but the universe's largest stars live lives that are brief, brilliant, and often violent. Unlike smaller stars that burn steadily for billions of years, hypergiants exist on borrowed time. Their immense mass creates intense pressure in their cores, causing them to burn fuel at unimaginable rates. They live fast, shine brighter than millions of suns, and in cosmic terms, they die young. As these titans age, their cores evolve through a series of nuclear reactions. Hydrogen burns into helium, helium into carbon, then oxygen, and onward through heavier elements like neon, silicon, and iron. Each stage is shorter than the last, a countdown accelerating toward an inevitable climax. The heavier the star, the faster this process unfolds, like a candle burning at both ends. Eventually, the star reaches a point where fusion can no longer sustain it. Iron accumulates in the core, a material that cannot release energy through fusion. The outward pressure falters, and gravity wins. The core collapses in an instant, compressing matter into unimaginably dense forms. And then comes the explosion, a supernova, one of the most powerful events in the universe. During a supernova, the outer layers of the star are blown away at incredible speeds, shining brighter than the combined light of billions of stars. For weeks, the explosion can be visible across vast stretches of the galaxy. Elements created in the star's core are scattered into space, seeding future stars, planets, and even life itself. In a way, the death of a hypergiant is also a beginning, a gift to the universe that will continue for eons. Some of the largest stars may not even leave behind visible remnants. Their cores collapse into black holes, regions of space where gravity is so intense that not even light can escape. These black holes are the ultimate tombs of cosmic giants, invisible yet immense, continuing to influence the universe long after their brilliant lives have ended. And while we cannot witness every supernova in real time, we can imagine it. Picture a star so enormous it dwarfs our entire solar system. Its surface is a seething ocean of plasma, trembling as gravity tightens its grip. Suddenly, it detonates in a burst of energy that would outshine the night sky. A final, magnificent heartbeat of existence before disappearing into darkness. Even in death, these stars are teachers. They remind us of the impermanence of life, the inevitability of change, and the beauty of transformation, on a scale far beyond human comprehension. The biggest stars may live briefly, yet their influence ripples across the universe, shaping galaxies, creating elements, and leaving a legacy that echoes through time and space. As we continue, we will journey toward the farthest reaches of the cosmos, seeking stars even larger than UY Scuti, and exploring the mysteries that remain hidden beyond the veil of our telescopes. Chasing shadows, the universe's hidden giants. Even with our most advanced telescopes, the universe keeps secrets. For every star we have discovered, there may be countless others hidden behind clouds of dust, cloaked in darkness, or so distant that their light has not yet reached us. The quest to find the biggest star is not just about measurement. It is a journey into the unknown, a challenge to our understanding of how massive a star can truly become. Astronomers peer across the Milky Way and into faraway galaxies, scanning for stars with extreme brightness and size. They use instruments that detect not only visible light, but infrared, radio waves, and even X-rays. These allow them to see through cosmic dust, to catch the faint signals of stars that would otherwise remain invisible. Each observation is a clue, a piece of a puzzle spanning millions of light-years. Theoretical models suggest that stars larger than anything we have yet observed may exist. Some could be early generation stars, formed when the universe was young and heavy elements were scarce. These population 3 stars might have burned with unimaginable intensity. Their lifespans brief, but their influence enormous. They may no longer exist, or they may have collapsed into black holes, leaving only gravitational whispers of their presence. Yet even in our own galaxy, the largest stars are difficult to confirm. Observations often reveal variability. Stars expand and contract, shed outer layers, or experience eruptions that change their appearance dramatically. One moment, a star might seem larger than any other. The next, it shrinks under its own instability. The universe is constantly reminding us that size is not absolute. It is fleeting, dynamic, and shaped by forces beyond our control. Imagine drifting in a spacecraft through this distant darkness. You pass nebulae glowing softly, like lanterns in a vast cosmic hall. Stars appear as points of light, some small, some enormous, each telling a story. Somewhere in the distance, hidden behind veils of dust, may exist the ultimate giant, a star so vast it surpasses UY Scuti, so immense that even its light is stretched thin across space. We cannot see it clearly, yet its existence is possible, a testament to the extremes that nature allows. These hidden giants challenge our imagination. They are reminders that the universe is bigger than we can comprehend, and that even as we map the stars, mysteries remain. The biggest star is not just a number or a measurement. It is a question, a symbol of the unknown, calling us to explore further, to look deeper, and to wonder at the unimaginable. And tonight, as you listen, picture one of these elusive titans. Its presence is felt, even if unseen. Its energy radiates across the cosmos, a quiet roar in the darkness, a reminder that the universe always has more to show us, if we are patient enough to look. In the next section, we will explore how these immense stars shape their galaxies, influencing the birth of new stars, the formation of planets, and even the structure of the cosmos itself. Giants that shape the cosmos. The universe is not just a collection of stars drifting aimlessly in space. Every star, especially the largest, plays a role in shaping the galaxies around it. Hypergiants are not merely isolated giants of light. They are architects of cosmic evolution, influencing the birth of new stars, the distribution of matter, and the very structure of their surroundings. When a massive star burns, it emits enormous amounts of radiation and stellar winds, streams of charged particles that flow outward at incredible speeds. These winds can sculpt nearby clouds of gas, compressing some regions while dispersing others. In this way, a single hypergiant can trigger the formation of new stars while preventing star formation in other areas, a delicate balance of creation and destruction. And when these stars die, their influence becomes even more dramatic. A supernova explosion releases more energy in a few weeks than our Sun will emit over its entire 10 billion year lifetime. The blast waves push and compress the interstellar medium, creating shock fronts that ignite fresh rounds of star formation. Elements forged in the star's core, carbon, oxygen, iron, and heavier atoms, are scattered across space, seeding the universe with the ingredients for planets, moons, and even life itself. Some hypergiants collapse into black holes, invisible yet powerful, pulling in nearby matter and shaping the dynamics of their galaxies. Others may end as neutron stars, spinning rapidly and emitting jets of energy that can be detected across millions of light years. In every case, the death of a giant is not an end. It is a transformation, a redistribution of energy and matter that ripples across space and time. Imagine floating near a supergiant as it nears the end of its life. Its surface roils with turbulence. Gas eruptions burst into space, glowing softly before fading into the surrounding darkness. Then comes the sudden, blinding flash of a supernova, an explosion that briefly turns night into day across vast cosmic distances. In that moment, the star's life and death are intertwined, a spectacle of creation and destruction that reminds us how interconnected the universe truly is. These giants also help astronomers understand the evolution of galaxies. By studying their life cycles, we can trace how elements spread, how star clusters evolve, and how galaxies form their structure over billions of years. In essence, the larger stars are both markers and makers, signposts of cosmic history and agents of change in the universe's grand design. So as you listen tonight, picture these massive stars, not just as distant lights, but as living forces shaping the universe. Their influence extends far beyond their size, touching galaxies, stars, planets, and even the potential for life. They are silent giants, unseen architects working quietly across the cosmos, leaving traces that will outlast their brief, brilliant existence. In the next section, we will explore the mind-bending scales of distance and time that separate us from these giants, and what it feels like to truly grasp their immensity. Across light years and eons. When we speak of the universe's largest stars, it is impossible to ignore the mind-bending scales involved. UY Scuti, Betelgeuse, and other hypergiants exist thousands, even millions of light-years away. Light itself, the fastest traveler in the cosmos, takes that long to reach us. When we look at these stars, we are not seeing them as they are now, but as they were when their light began its journey, a glimpse into a past that may no longer exist. To put this in perspective, 1 light-year is nearly 6 trillion miles. Multiply that by thousands, and the distances become almost unimaginable. Traveling to one of these stars at the speed of our fastest spacecraft would take millions of years. Yet, through the patient observation of light, we can measure, study, and understand them. The universe allows us a window into these colossal giants, even if we cannot physically touch them. Time is another factor that emphasizes their fleeting existence. The largest stars burn through their fuel at incredible speeds. A star like UY Scuti may live only a few million years, a heartbeat compared to the 10 billion year lifespan of the Sun. In cosmic terms, these giants are brief sparks in the darkness, brilliant and fleeting. Their light, however, travels vast distances, meaning we can witness their existence long after they have vanished. This interplay of distance and time creates a strange reality. We see stars that may no longer exist, yet their energy continues to shape galaxies, trigger star formation, and scatter elements across space. The light arriving in our telescopes tonight may be a memory, a cosmic echo of events that occurred eons ago. It is both humbling and mesmerizing, a reminder that the universe operates on scales far beyond human comprehension. As you drift through this thought, imagine floating in the void, surrounded by galaxies, each containing countless stars, each star a distant sun with its own story. Somewhere, far beyond the reach of our vision, exists the ultimate giant, perhaps larger than anything we have measured. Its light is traveling silently across space, a quiet reminder of how immense, mysterious, and alive the cosmos truly is. Understanding these distances also teaches patience. Astronomy is not about instant answers, it is about waiting, observing, calculating, and dreaming. We study what is far away, we imagine what is hidden, and we piece together the grand story of the universe, one faint beam of light at a time. In the final section, we will draw our journey to a close, reflecting on the awe-inspiring wonder of the universe's largest stars and the lessons they leave behind for us, both scientifically and philosophically. The quiet majesty of giants. As our journey nears its end, take a moment to let the vastness of the cosmos settle around you. Imagine the enormous stars we've explored tonight. UY Scuti, Betelgeuse, and the theoretical giants that may lie beyond our observation. Each one is a beacon of power and scale, a reminder that the universe is unimaginably large, full of mysteries that stretch both our minds and our imagination. These stars, for all their immensity, teach us humility. They live and die on timescales far beyond human experience, yet their presence affects everything around them. They remind us that life, even at its largest and most powerful, is fleeting. They shine brilliantly, but they burn fast, and eventually they vanish, leaving only their light and their influence behind. There is also beauty in their instability. Unlike the quiet, steady sun, hypergiants pulse, expand, and erupt. They are alive in a way we can scarcely comprehend, constantly reshaping themselves and their surroundings. Observing them teaches patience, attentiveness, and reverence for forces far greater than ourselves. As you lie back, eyes heavy and mind calm, let yourself drift through the darkness of space. Picture a hypergiant stretching across the horizon, its surface a soft, pulsing glow. Imagine the light traveling across thousands of light years, finally reaching your eyes as a quiet whisper of its existence. In its glow, see both power and fragility, brilliance and impermanence. And remember, the universe is full of these giants, some known, some hidden, each a testament to the unimaginable scale of creation. Even if we never visit them, their presence shapes everything. Galaxies, planets, life itself. They are silent teachers, reminding us that there is always more to explore, more to wonder at, and more to understand. So tonight, as you drift towards sleep, carry with you the image of these titanic stars. Let your mind float among them, calm and serene, marveling at their scale, their life, and their quiet influence across the cosmos. And know that in the endless universe there will always be giants, waiting silently, glowing faintly, and inspiring awe in those who dare to look. Sleep now, gently, beneath the vast canopy of stars, surrounded by the wonder of the cosmos and the quiet majesty of giants.